In this video, I'm going to show you how I use simulations to teach scientific practices. And specifically, I'm going to focus on scientific questions, which is a great way to initiate a simulation to a classroom of students. So I'm going to use this enzyme diversity simulation that I have. And one of the first questions I ask students is, what are the inputs and what are the outputs? This is the basis of a scientific experiment. What's the independent variable and what's the dependent variable? What is the cause and what are the effects? And when we run a simulation, we see that these are the inputs, which we can manipulate. And then these are the outputs. Well, what are those outputs? They're products of pepsin catalysis, products of amylase catalysis. And this gives a good dialogue to understand what is pepsin catalysis, what is the product of pepsin catalysis, and then it allows students to start focusing on what is this simulation about? What is the domain of applicability for this simulation? What applies, what does not apply? And after I get through talking about the possible independent and dependent variables of the simulations, then I move through to scientific questions. So what kind of questions can be answered with this simulation? And one of the good questions is, I'm going to click live, which will update the data live. When I start manipulating my inputs, what enzyme acts on what substrate? So how will my products of pepsin catalysis change in response to which of these substrates? And let's go through and see if we can figure that out. So I manipulate protein, which I thought it was, and it is, but it's not changing. Well, one reason is it works in a pH of 3. So here I get to see when the pH is at 3, then the protein does change. Well, how about some of the others? Well, nucleotides don't change at a pH of 3, lipids don't change at a pH of 3, and starch does not change at a pH of 3. But what does is the protein. So that enzyme, in some ways being regulated, catalyzed, is catalyzing the breakdown of that protein molecule, generating this product that we see. All right, so I have students kind of figure out in a game-like way what of those substrates are acted on by which of the enzymes. After I do that, I'll have them pick an enzyme and say, okay, what is its optimal temperature and what's its optimal pH? For pepsin, we can drop all these nucleotides down, lipids, starch, and go through and say, what is its optimal pH? And there's different ways to go about doing that, and you can manipulate and run experiments. One thing you can do is here, we can just run experiment after experiment after experiment, and using that, we can then collect some of that data. After I've gone through kind of the scientific questions that this simulation was built around, I have students, okay, ask students, what are some errors in this simulation? What are the errors in this model? I'm human, and I know I make errors in every simulation I make. And then lastly, the last scientific question I like to ask is, what questions about enzymes are outside of the domain of applicability in the simulation? What questions about enzymes can this simulation not address? Things like questions about where these are expressed in different cells, or how do cells all with the same genome express different enzymes in different cells? Those are questions outside of this simulation, but still about the enzymes of this simulation. So this video was about scientific questioning. Focus on the inputs and outputs first, just so students get to see what the simulation is really about. Then have them ask certain questions that could be answered, and then focus on the questions that can't be answered by the simulation.